Welcome back. Let's solve two questions by using the Pythagorean theorem. So we have triangle in here like this and another one in here, and this is 90 degrees and this is 90 degrees, and A, B, C, and let's call this D. AB is perpendicular to BC and AD is perpendicular to AC. AB is equal to, let's say, 2, and BC is equal to let's say 5, and AD is equal to square root 12. Okay, find DC. Okay, so let's find it. 2 square plus 5 square is equal to AC square. 4 plus 25 is equal to AC square, which is equal to 29. Take the square root of both sides. This is gone. AC is equal to 29. I'm not going to write it again. So, square root 29. Now, let's find DC. Square of AD, like A square plus B square, is equal to C square. I'm going to do the same thing in here. Square root of this one, okay? Then, square root of this one is equal to DC squared. These are gone. 12 plus 29, what is it equal to? If it was 30, 42, 41 is equal to DC squared. What is DC equal to? Take the square root of both sides. Square root 41. That's it. Okay, one more question. Then I'm just gonna talk about the special triangles. Let's say, okay. Let's assume that this is 90 degrees, okay? And this is also 90 degrees. A, B, C, D. AB is equal to 3. DC is equal to 5. And BC is equal to, let's say, 2 square root 8. Okay? Find AC plus DB, the lengths of them. Okay, let's find it. So we have two triangles, one in here, the other one in here. Okay, so let's start with the yellow one. What do we have? The hypotenuse is occupied, the AC is absent. Then 3 square plus AC square is equal to 2 square root 8 square. 3 square, 9. AC square. Now, how am I going to find this one? Two ways. You can take the 2 and put it inside the square root. But if it's entering, it's going to first knock on the door and square itself when it's getting inside. If it was cube root, it was gonna cube itself. So that's one way of doing it. Or you can just independently take their squares, like 2 square, 4, square root 8, square, 8. Both of them are fine. Let's do this one, the first one. Square root 32. Okay? And if you take the square of it, 32. And AC square is going to be equal to minus 10, 22, 23. Then AC is going to be equal to Take the square root of both sides. Square root 23. AC. Square root 23. We found this one. Now we are gonna apply the same thing for BDC triangle. What do we have? 5, right? 5 square plus BD square is equal to 4 times 8, 32. 32, but yeah, 32. If I take the square of it, 4 times 8, 32. 25 plus BD square, 32, right? 7. BD is equal to square root 7. Square root 7. And the total would be AC square root 23 plus square root 7. You can calculate it if you like. Okay, now let's talk about some well-known triangles. Special. Triangles. Okay. First one. Well. It's all about the ratios, okay? 3K, 4K, 5K. What is this K? You can put 2 to K, then what would happen? Multiply it by 2. 5 can be, for example, 10, 8, and 6. Same thing. Right? Just the same thing. Or multiply this again with, maybe let's say 3. Then what's going to happen? 30, 24, 18. It's the same. That's the first one. The second one, when this is right triangle, of course. If it's not right triangle, you can say this is like 3, 4, 5. It doesn't apply like that. Now, another one. 5K, 12K, 13K. Okay? And the same also goes on to here. You can also encounter with like maybe times 4, right? 20, 52, and 48. Okay. Next one. $8K, 15K, and 17K. Next one. $7K. These are all perpendicular. Please keep that in mind. 7K, 24K, and 25K. I think that's it. Yeah. These are for the lengths of the sides. Now let's talk about the special angles. Special angles. I mean, it's under the subcategory. It's a subcategory of triangle. 30, 90, and 60. 90, 30, and 60. Across 30, the smallest one, 1. The highest one, 90, 2. And square root 3 comes right across 60. And it is less than 2, obviously. The hypotenuse is the longest one, all the time, in the right triangles. What's confusing about this is, sometimes teachers like to confuse the students' minds, right? And they maybe flip the triangle like this, and let's say this is 30, 60, 90. Sometimes instead of writing 1, or it's easy to write, for example, multiply everything by 2. Okay, 2, then 2 square root 3, and then 4. But sometimes we like to give students something like this, square root 5. What happened now? What are you going to do? Easy. I just multiplied 1 with square root 5. I'm going to multiply everywhere, each side with square root 5. Then square root 5 times square root 3 is equal to square root 15. Square root 5, right? Then again, 2 times square root 5. That's it. The other one is 45, 45, 90. Okay? This one. Let's make it light, a bit light. 90, 45, and 45. The ratio again, 1 square root 2. Why is it like that? I mean, come on, 1 square is equal to the hypotenuse square, right? What is it equal to? 1 plus 1, 2 is equal to hypotenuse square. Take the square root of both sides. See? Then this is equal to square root 2. These are cancelling out each other. Square root 2. That's how it is. Or some people like to do it like this. A or X doesn't matter. A times square root 2. Same in here. A square root 2 times, right? And this is 2a. Doesn't matter. Doesn't really matter, yeah. And the other one is like this. The other one is like the derivative of it, actually. Like it's just the same thing, okay? Let's do it like this. 3, 4. Yeah, close, anyways. Let's say this is 110, 20. Let's say this is 30 degrees. This is 30 degrees. A, and A square root 3. Why? Easy. Same thing. What happened now? Divide it from here. What happened? 110, 20 now is equal to 60 and 60, right? That's what we have. Now what happened? 90. I told you that 90 was like 2a, right? Now everything is divided by 2. That means it was square root 3, right? Normally. Square root 3, a square root 3. Now divided by 2. Same thing. Divided by 2. A over 2. Same thing. And when you add them up, what happens? This whole thing becomes a square root 3. That's it. And one last thing, it's not really asked, but I just wanted to show it to you. 1575, that degree, yeah. I may be a little bit like, no, wait a second. Let's do it like a little bit, let's bend it this way. This is the right side. Okay. Let's say this is 75. This is 15. From 90 degrees is coming to here, right here. If this is h, the ratio of this one is 4h. Just wanted to share that, okay? And now, do we know how to find the area? In area, in triangles, base length times the height over 2. This is the area of, let's say, ABC triangle. Area. Okay. And how can we find it? Let me give you an example. This one is easy. Let's say 5, 12. Find the area of this one. 5 times 12 divided by 2. I mean, let's imagine this is a rectangle. Okay. Normally, finding the area of rectangle is the multiplication of two sides, 5 times 12. Now what happened? I cut it in half diagonally, and now I divide it by 2. But when students see something like this, they're having some difficulty, but it's the same thing. Let's say this is 15, and the height of this one is, let's say, 10. Okay? The height of it. Same thing, 10 times 15 divided by 2. Okay? There is a formula for finding the area of quadrilateral. Quadrilateral. What I couldn't just say, I started, sorry. So the angles and the sides are same. Okay? 60 degrees, 60 degrees, and 60 degrees. The inside angles, the addition of them has to be 180 degrees. Okay, that's the thing. It's really important to know. So, how can we find it? A, B, C, right? A, B, C. Quick formula, area of A, B, C is equal to A square, square root 3 divided by 4. Okay, if this is A, one side is A. If you forget this, what are you going to do? You're just going to calculate the area of two triangles. We're going to divide this one. This is becoming 30, this is becoming 90. Divide by everything by 2, right? This was square root 3 divided by 2. No, this was actually A. A divided by 2, huh? This one, 60 is seeing this one. A square root 3 divided by 2. This is A over 2, right? What's happening? A times A square root 3 divided by 2, right? Then I'm dividing it to 2. Why? Because base times the height, right? Base times the height divided by 2. This is also equal to times 1 over 2, dividing the whole thing. And that is equal to, right here, a square, square root 3 divided by 4. Okay, and one last thing. One last thing about triangles, finding the length. Let's suppose we have a triangle, and inside, let's say this is point P, and let's say this is L, K, M, A, B, C. If AB is parallel to PK and AC parallel to MP and BC parallel to PL, then this side, let's call this one X, one side. X would be equal to PK plus PL plus PM. Okay? If they are, of course, parallel. Like this is parallel to PL to BC. Okay? And the same for other. These are parallel to each other. Okay. Before I move on to the next video, I'm just going to show you some examples from the unit circle. As I mentioned in the previous videos, pi was equivalent to 180 degrees, right? And in here, I'm just going to ask you some questions about some degrees. Okay. Yeah. So find the exact values of A sine 4 pi over 3, B cosine 4 pi over 3. After this example, I'm gonna finish the video. C tangent 4 pi over 3. Okay. So, what is 4 pi over 3? Let's first find that. Excuse me. Pi, 180, right? Pi is equal to 180. 4 times 180 divided by 3. What is it equal to? 60, 240. It's actually asking me find sine 240. Let's draw it. 240 is gonna be like here. So this is 270, right? 40 here. 30 degrees less. I told you this was 1, right? It's asking the length of this one. What? Sine, right? Length of, what's the length of this one? This is 90 degrees. Okay. So, how am I gonna find it? This is 60 degrees. What was the ratio? Calm down, just draw it. 60, 90. 1, square root 3, and 2, right? My God, now, this is not 2 in here. The radius is 1. Divide everything by 2. Now, 1, square root 3 over 2, 1 over 2. Write it. Square root 3. This is 1 over 2. Okay? Now, it's asking me, what is it asking me? The length of it, right? Yeah. So, sine 4 pi is going to be equal to sine negative square root 3, the length of this one, right? Right here. Okay, how about this one? Let's actually, you can also use Desmos in here. Oh, I don't have internet. Let's turn on the internet. Okay. So let me just show you. Before we begin, x squared plus y squared is equal to 1. See, we have a circle in here. Okay, so we were asked sine 240. Okay, 0.94. Square root 3 is equal to I think I did something wrong in here. This is divided by 2. Divided by 2, yeah. So now we have it. Divided by 2, yeah. Okay. In that case, the answer is this. Divided by 2, let's see. Oops. Square root 3 divided by 2. 0 point sine 86. But this is wrong, I think. Sine 240. Is this like degrees? Let's ask to here. Sine 240. Yeah, 0.94. This is in radians. In degrees, let's do it again. In degrees, sine 240 is equal to, see, negative 0.86. Yeah. Same with this one. In come to decimals, it's negative, right? So we are correct. Now let's find B. Cosine 4 times 180. It's the same thing, 240. Cosine 240 is equal to, let's draw 240, we derive it. Then let's look at the reflection on the x-axis, y-axis, because this is cosine and this is cosine, which is equal to negative 1 over 2. Negative 1 over 2, okay. Now, moving on to tangent. How are we going to do it without the calculator? Sine 240 divided by cosine 240. Tangent was also sine over cosine. Right? Sine is in here, in the third quadrant. Sine is negative. Cosine is also negative. Negative divided by negative, positive. So I will have something positive. That's it. Let's write it. Sine negative square root 3 over 2 divided by negative 1 over 2 is equal to negative 3 over 2 times negative 2. These are gone. These are gone. Plus, the answer is square root 3 for this one. Okay, thank you so much for listening. See you in the next video, next lesson.